Hello and thank you everyone for attending today's webinar, Save a Ton with PLM Parts Classification, Virtual Webcast and Industry Panel, brought to you by Design World Magazine and PTC. We'd like to thank our whole panel of speakers for being here today. This webinar will feature industry insight from Graham Birch, Catherine Trad, Louis Lawrence, Brian Iwerks, and lastly, I'm Mike Santora, Associate Editor for Design World Magazine, and I'll be your moderator. Just a couple of housekeeping details before we get started. You will see several boxes on your desktop, all of which can be moved around to suit your preferences. Initially, the Q&A box is on the left-hand side of your screen, and this is where you will enter your questions for the Q&A session. Another box to note is the additional resources, initially in the lower left-hand corner of your desktop. These resources are for your information needs. There's also a taskbar at the bottom of your screen to help you navigate the webinar. Our broadcast today will be 90 minutes long. In the first hour, our presenter will give a slightly different angle on how their company tackled their parts classification initiative. Then, in the last 30 minutes, we will open the conversation to the audience with a live panel discussion. Catherine, or Cat Trad, Parts Link System Administrator at Solar Turbines, will present first today and will focus on the what behind parts classification, metadata, and the value it brings across various cross-functional teams. Kat graduated with a BS in Mechanical Engineering degree from the University of Texas at Austin. In her 10-year career with Caterpillar and Solar Turbines, she has served in roles of increasing responsibility in manufacturing engineering, production supervision, supply chain, Six Sigma, and most recently as the Enterprise Business Process Lead for Part Taxonomy and Part Link System Administration. Kat leads an enterprise taxonomy governance team, sets part metadata strategy, and supports the enterprise in benefiting from taxonomy best practices. Brian Iwerks, Engineering Manager of Systems and Processes at Daktronics, will be presenting second today and will focus on the why behind parts classification and on the challenges that Daktronics faced while implementing this project. Brian has more than 20 years of experience in product development, product management, and related processes and systems. Brian leads the team responsible for the development and deployment of PLM engineering tools and associated processes at Daktronics. Louis Lawrence, IT Manager at Weatherford, will be taking us through the how of parts classification and will wrap up the industry presentations. Louis manages a fantastic team responsible for Weatherford's Windchill implementation, supporting 3,000 users with 3 integrated CAD systems, change management, configuration management, and part classification. He is a long-term PTC user and a presenter, and also a strong proponent of tea breaks. Moderating the session today will be Graham Birch, Senior Director of Solution Management at PTC. Graham will be giving us a brief introduction of today's topic, and then we'll be moderating the remainder of the session, including the live panel discussion. Graham is a Senior Director of PLM Solutions at PTC, responsible for core Windchill, change, configuration management, collaboration, product management, search, classification, supplier management, and Windchill runtime. Graham started his career in the UK after graduating from the University of Manchester Institute of Science and Engineering. He has 30 years industry experience, and his past roles include applications engineer, implementation consultant, director of R&D for PLM products. And that wraps up our introductions today. At this point, I'd like to hand it over to Graham. Graham, take it away.
Hello, everyone, and thank you, Mike, for the introduction. So today we're going to be talking a lot about parts. And although the evidence for the use of replaceable or interchangeable parts can be traced back over 2,000 years to the use on Carthaginian warships, the concept was not really developed until a royal order in 1765 by the French government demanded the standardization of armaments for the French army. So prior to this, all muskets were hand-built. And if a musket needed repair, then the whole weapon had to be taken out of service for repair by a skilled gunsmith. But with the introduction of standardized components, new parts could be installed in the field, and the musket can be quickly returned to service. So the concept of replaceable parts really started to revolutionize how we think about the products that we assemble. And obviously things really took off with the introduction of the assembly line, and really manufacturing has never looked back. And now the concept of building products from interchangeable parts, built to specific specification, is fundamental to how we engineer products, from the very simplest to the most complex. And as we move and transform ourselves from manual to digital methods to describe parts, it's become apparent that capturing high quality part metadata, and by that what I mean is the metadata is the information about the part. The ability to capture that information early on in the life cycle of the part, ideally at its inception when it's created, can yield tremendous value downstream, including reduced part duplication, reduced testing and verification effort for new parts, lower inventory costs, and so on. I'd like to expand on just one such example, the potential savings that can accrue as a result of simply reusing an existing part rather than creating a new one. So to understand this, we first begin by understanding the carrying costs per part. So this obviously varies considerably by industry, but by the time you take into account things like storage and tooling and validation, sourcing, storage, handling, etc., then industry kind of agrees that $5,000 a year for a part in inventory seems to be a reasonably accepted number. So let's take that as data point one. And now if a company introduces, let's say, about 3,000 new parts a month, and that's kind of anecdotal data taken from some of our own customers here at PTC. So let's say we're introducing about 3,000 parts a month, and let's say we could only save 2% of those parts by reuse. So in other words, instead of creating a new part, manage to find another one that's either exact match or is really good enough to satisfy the immediate need. So let's assume we can save 2% by reuse. That would actually yield an annualized savings of $3.6 million per year saved just by part reuse alone. So it's clear that managing parts is critical to managing costs and driving up quality. And parts classification can be a critical tool to managing your digital parts inventory. And it has two huge benefits. Like firstly, it encourages part reuse by making parts easier to find. And then secondly, it allows engineers to attach high quality, clean metadata to the part, which will pay dividends downstream. So in this panel discussion, we have three industry experts who will share their experiences with deploying parts classification. And with that, I'd like to hand the microphone over to Catherine Tradd of Solar Turbines as the first of our panelists. So Kat, take it away.
Thank you, Graham. So I love libraries, real honest to goodness book and paper libraries. And I think I like them so much because when you walk in, there's just an elegance to the way that books and that data and information is stored so that you can easily find what you're looking for. And when I think about a Windchill database as it is used by Solar Turbines, that is genuinely our digital library of part information. And I don't know if it's because data is kind of invisible and that ones and zeros are sort of easier to ignore than books and paper, but without sort of our classification and attributing system, our database would be incredibly unsearchable and it would be very difficult to find that information. So the ability to classify and attribute and have that clean metadata and make that information searchable is extremely powerful for us. So a little bit about solar. So products from Solar Turbines play a very important role in the development of oil, natural gas, and power generation projects around the world. We make gas turbine engines, gas compressors, gas turbine powered compressor sets, mechanical drive packages, generator sets. And we really help power the world, so an energy solution company. So one of the things we thought about as we were conceptualizing this event is we wanted to give you some context, sort of a side-by-side comparison of Solar, Daktronics, and Weatherford and how we utilize PTC products, how big our database is, and that kind of stuff. So Solar is a wholly owned subsidiary of Caterpillar Inc., which is a Fortune 50 company, so our revenue is in line with that. The total employees of Solar Turbines is around 7,000. We utilize Windchill with PDM Link, Parts Link, Project Link, and NPM Link. We also utilize Creo and Option Modeler. We've been using Windchill since the year 2000, and we've been utilizing Parts Link and Classification since 2009. Our total Windchill users are just over 5,000, and the total parts in our Windchill database is around 1.6 million. The classification nodes in our structure are around 2,000, and we've classified about 400,000 parts of the database. We average around 13,000 parts created per month, and of those that are classified is around 4,400. So just as a warm-up exercise, if you were to ask a team of people what this is, you would get a variety of answers. You might get the answer flashlight. You might get the answer hand light. You could see someone say torch. You could see someone say LED light. And that's great and that's terrible. What's great about it is people are coming with all kinds of diverse experiences and backgrounds to try to describe something. What's terrible about that is when you come with all of these different starting points, sometimes it's really difficult to search for that information. What's really great about a strong metadata structure is no matter what you come into that search with, everyone should leave with the same conclusion. So in my part of the talk today, I want to talk about the importance of naming, keeping metadata in perspective, and really why now. And the takeaways are looking at how strong part metadata produces searchability, database quality, analytics opportunities, and cost savings. So I do have a confession to make. Even though I'm a PartsLink system admin now, when I started out, I was a terrible part author. I was really a triple threat. I was new to Solar's products, I was new to Windchill, and I really hadn't even a concept of what metadata was or how much of a parts legacy I was leaving in the system by creating either deficient or incorrect part metadata. So let's talk about what metadata is. So for me, it's really the classification structure, the attributes that go with those classification nodes, and then the name that's driven from those things. So let's take this example out of the technical world for a second and talk about something that we might do in our personal lives, which is adopting a pet. So if you go to a shelter and you ask for a pet, they could bring you just about anything. And I don't know about you, but if I came home with a reptile, I don't know that I would be allowed back in the house. No offense to anybody who loves reptiles. But what I would really go looking for is a dog. And in the case of a dog, that's not quite enough information because they could bring me any dog, and maybe I don't live in a place that lets me have a big dog. Maybe I need a smaller one. So we add some attributes to the classification of dog to understand the sort of variations of dog that we have available to us. So in the instance of the husky, the size is medium, the eye color is blue, the coat color is black and white. But that's not quite enough information yet either. What we really need to do is to be able to describe what we want. So if we say, okay, when asking for a dog, we're going to use this naming rule. We're going to talk about the type of pet that we want. But then we're going to talk about the primary breed and then give me one specific feature of that primary breed so that I can quickly understand if it's there or not. All of a sudden when we say, hey, I want a chocolate lab, wow, it really dials it in. And we can understand if the shelter has that pet or if not. So when it comes down to it, the classification dog attributes describe the classification, and then having a consistent name that is derived from the classification and attribute data makes the system extremely searchable. So why is this important to a company like Solar? So as a company that makes products that are incredibly large and durable and long-term investments for our customer base, it really matters to us to understand what we sell over time to our customers. So some of our customers have been running their products for 30, 40, 50 years. And those customers want us to be able to service that equipment for the lifetime of that equipment. So we not only have an extremely long product lifetime, but we have a extremely rigorous service cycle for that equipment. So being able to search for parts and understand the change management of those and have that metadata available to be able to let it evolve with the product is very important to us, being able to serve our customers in the best way possible. So let's talk more about metadata. And I love this cartoon because it really helps conceptualize that different people in an organization are both going to see an object differently, and they're going to see the metadata on that object differently. So as they look at this elephant, the guy at the front is looking at the tip of the tusk as a spear, and the guy at the back is seeing the tail as a rope. Well, when you look at metadata from different perspectives in an organization, people are going to utilize it differently and may need it to be different things to different people. So let's talk about those parts of the organization. So who really cares about metadata? Well, engineering sure does. I think that's sometimes the easiest parallel to draw for us in the technical world. But marketing cares, analytics cares, logistics cares, and supply chain cares. Accounting and finance and your aftermarket group absolutely cares, and ultimately your customer cares, because if all those groups can't perform effectively, the customer is not going to get the type of service that they need. So let's talk about some of the benefits to each of these groups. So for solar, one of the most prominent benefits we got from classifying and attributing our part database is standardized naming. I can't tell you how difficult it used to be to search in our Windchill database when we spelled transmitter 10 different ways. That allowed us to really start maximizing part reuse, minimizing duplicating parts and drawings. And then Graham was talking about carrying costs, but the act of maintenance of parts and drawings and maintaining the database also takes time and money, and reducing that and optimizing that is a definite benefit. Minimizing that duplicated effort and then actually being able to find similar or analogous parts in the system definitely benefits your engineering group. So beyond that, your logistics team is looking at benefits of reducing delays and fees, of making certification and compliance a little bit more straightforward and standardized. And then also, if you're a global company or shipping to a global customer base, being able to translate the items that you're selling into different languages can be an extremely powerful tool. I would hate to have to be a translator who had a part name come across my desk that was XMTR, which meant transmitter. Very difficult to translate that. So supply chain also cares. So that ease of translatability is huge. Standardizing external communications, so all your supplier communications, being able to know that if it's named a transmitter, it's always a transmitter. Being able to do some cross-classification analysis. So there's a lot of conclusions you can draw by looking across your nodes at different features that parts have. So maybe by looking at everything that's a forging or everything that's made of stainless steel, you can really start to draw some parallels and start to understand more of your supply chain data. Also, optimizing inventory levels is a powerful tool of having parts classified and being able to utilize metadata for analytics. So marketing cares. So marketing has to do a lot of communicating of your engineering data, and being able to optimize search engine results because you have consistent naming is a huge benefit to this group. So for aftermarket, I don't know about your organization, but our aftermarket group either suffers or benefits the most by our metadata production. So really, they benefit from every single feature that all the other groups have that we've talked about thus far. But their ultimate goal is to reduce unplanned downtime for our customers and support the customer need, whatever the cost. And if they have difficulty searching for and finding replacement parts or being able to arrange service, we are failing our aftermarket team and our customers. So accounting and finance. Optimizing pricing strategies and inventory levels are huge for this group, and that part classification is key. Your analytics group. So there's ways to innovate that we haven't even thought of yet. And by having part metadata be able to feed some of these analytics analytics minds, you can innovate for optimization and efficiency that we haven't even moved forward with yet. And lastly, the customer. The customer is looking for the best product at the best price. And unfortunately, I don't ever anticipate having the experience where someone's going to come clap me on the back and say, hey, your part metadata is the best we've ever seen. We're so excited about that. You just keep classifying solar. But the difference is that when a service parts representative needs to look for something, they can find it immediately. When an engineer is trying to put something in a design, they don't create something new. They use something that we already have, that already has a source of supply, that's already certified and approved. It's that we are able to function as a business with the same efficiency and elegance that walking into a book and paper library and finding the book you're looking for has. So I hope I've convinced you that your entire enterprise can benefit from a strong metadata structure and by applying that consistently in your part database. So Solar's journey was not a short one. We've really been working on this for the past 10 years. And back in 2009 was really the first time that we had a team that attempted building our classification structure really gain traction. And that was because we had line of sight to Windchill 9.1, which had parts link available in it, and it was the first time we were able to implement our naming rule, which was a customization at the time. And what that was doing was deriving the name from the classification and attribute data we put on the parts. So that team spent a lot of time designing our fundamental parts classification structure. From that point forward, as soon as we adopted Windchill 9.1, we very quickly went to 10.1, and then the next 5 years were really spent just taking our critical data set in our parts database and making sure that it was classified. And we still continue that journey to today. Currently, our database has matured to the point where we're actually classifying configurable objects now and doing some other experimentation with utilizing our taxonomy and our classification structure for other uses. And now that 2017 has rolled around, we're working on upgrading to Windchill 11 and really looking at database quality as a next big milestone for us. So why now? Why now is Windchill 11? I don't want to make any bones about it. Creating a classification structure is hard, and it's a lot of work, but the dividends it pays are huge. And there's two reasons that Windchill 11 really becomes, in my mind, a good business case to start this journey if you haven't already, or to reinvigorate the effort if it maybe has gone cold, which is that Windchill 11 out of the box gives you an auto-naming capability, which is that derivation of name from part classification and attribute data. And it also has the capability of doing bulk updating, which really gives the opportunity to maintain your database quality in a way that we've never had before. So, and it's really just this easy. A user goes and creates a part, picks a classification node, fills in the attribute data that you assign to that node, and then, boom, part record created, name auto-generated, and away you go. So in concluding my section, naming is super important. Metadata has different perspectives all over your enterprise, and Windchill 11 is a great reason to do this if you haven't already. So part metadata produces searchability, database quality, analytics opportunities, and cost savings, and I hope I have convinced you that metadata matters. So with that, I'm going to turn it over to Brian Iwerks, and I hope you enjoyed. Thank you.
Thank you, Kat. Good morning, everyone. I'm Brian Iwerks. I'm the PLM Program Manager at Daktronics. I'm going to talk a little bit about why Daktronics chose to classify, and then talk through some of the challenges we had as we went through the project. It's fairly recent in our past, so I can talk about it with some good recollection. We're the world leader in LED-based video, commercial, transportation, scoring, and timing displays. Here are a few examples of places you might have seen us. We've got about 450 Windchill users. Overall, you can see our part stats are an order of magnitude less than Solar Turbines and what you'll see from Weatherford. I think we're representing that mid-sized PTC customer. We've been using PTC products since the mid-90s. We moved to Windchill in 2008, mainly for managing CAD assets. and then we started using it for PLM in 2015 and launched classification in the spring of 2016. As we were planning our PLM initiative, part classification was something we recognized as a high-value must-have. Here's an example from before PLM. One of the design groups built these panels with common parts physically mounted on them. It was easier than searching for them in the ERP system and then visiting inventory to have a look. Eventually, pictures were taken of the boards and posters were printed for the other design teams. Obviously, this was not sustainable. If you look close, you might even notice that some of the parts are missing, as someone probably needed one for a project. Of course, we didn't do this for all of our parts. I think it was limited to these electrical parts and some enterprising engineers in those areas. But I know I've seen mechanical engineers with examples of the various fasteners stuffed in desk drawers. So it's not uncommon to do this sort of thing. During our PLM planning, we found a reference stating that engineers spend more than 15% of their time, maybe as much as 40%, searching for information. We estimated that searching with Windchill, including part classification, should be able to give us a modest search improvement that could save us thousands of engineering hours every year. Then you consider our cryptic text-based attributes, sometimes variable by department, hard to decode, and difficult to report. And we often hear that classification helps reduce duplicate parts. We don't think we have a problem with that, but classification may help us find out. Our classification journey overlays with our PLM launch because they happened fairly close. We had about 1 million parts in our enterprise resource system. We had to decide, do we want to move all those into Windchill? Ultimately, we said a lot of them are old, we don't care. Let's go with the ones we're using today, and that was about 220,000 that are active. And so we moved those, and then the question was, do we classify all of those? In the end, we chose to break that down into smaller chunks, and we focused on about 13,000 commodity parts. You may also hear me say piece or buy parts. They're those off-the-shelf things, someone else's spec, a resistor, a bolt, that kind of thing. It's easy to wrap your head around what it is, what classification it might fall into, what the attributes ought to be. We figured we'd start someplace reasonably simple. Today, I'm going to talk through some of the bigger challenges we had with implementing classification. The first was a lack of industry standards. Does everyone really have to reinvent the wheel? Are we really all that different? It does kind of seem so. So we developed our own tree, and while there's no industry standard, we did find some good examples for commodity parts. DigiKey and Silicon Expert were helpful for electronics. McMaster Carr was a great example for fasteners and for classification in general. If we had someone that came to us and said, hey, what's classification? We could take them to that site, show them, ask them to search for a bolt, and show them successfully how they go through the different classification structure nodes, and then see attributes at the end. It really helped. These aren't complete solutions, but they did help start the journey. Now, growing that tree took a lot of consensus building. We brought our subject matter experts together in a series of workshops. Those resulted in our initial classification tree and attributes. Now, at that point, we felt we had done some really good work, but we also thought we should probably go out and get some more feedback from the masses. In the end, that turned out to be a pretty good success story. During the same time that we were holding those classification workshops, the company was building this walkway between two of our larger buildings. Imagine a blustery winter day on the prairie of South Dakota, and you'll understand why this was such a popular addition. Now, one very creative member of my team saw it as an opportunity. He called it the Bridge to the Future. He hung posters of all our classification branches on the walls and provided clipboards for feedback. We did some promotion and called on users to stop and share their thoughts. It was a tactile way to get feedback without sending an email that would surely be deleted. Many people funneled through that walkway, and many were curious. Entire teams would stop and have discussions around the nodes that most impacted them, and it generated a lot of positive buzz. People were learning and talking about PLM and classification, and mind you, this actually happened before we launched our PLM initiative. So people didn't really know what it was, and they started to get some good impressions about it, which was very valuable. And they were happy that we were asking for their feedback. So there was a lot of goodwill from that. In the end, we got a lot of great feedback and had broad consensus on the tree. The next big challenge was converting the attribute soup encoded into our part descriptions into organized and accurate classification data. The example here in the inset was an early attempt to solve the problem with Excel formulas. I admit I tried it. It failed quickly. There's just too much inconsistency in our low quality data. We found the only way to get there was through manual spreadsheet work. So we pulled our ERP part data into spreadsheets as a starting point. Thankfully, our corporate sourcing team stepped up and took ownership of the classification and attribute setting, all that work. It was error-prone and tedious with many man-months of work, but it was a great opportunity to clean up the data. And they stayed amazingly positive during that exercise. Our third big problem was figuring out how to load all that data into Windchill. When we planned our PLM project, we were planning to use PTC's Counterpart tool. Unfortunately, Counterpart was deprecated in Windchill 10.2, and we didn't find it out until it was too late. We considered building or buying a custom tool, but we knew Windchill could load Excel and XML files, so we chose to go that way. We had hundreds of Excel files, one for each classification node. Getting them to load required attention to detail. Each node, attribute, and in some cases attribute values have unique IDs or tags. Those tags need to match exactly between the tree and the data files being loaded. We had many load errors from tag mismatches, so there was a lot of rework. It wasn't easy, but we figured out how to do it. And now the last big challenge that I'll talk about in my story today. After the tree was built, after the attributes were defined, and after we had a method to load the data, it was time to manage the migration process across our 3 test environments and into production. With so many files to manage, we chose to split them up into manageable groups. We planned 3 waves with about a third of our parts in each. Waves are about 3 to 6 weeks apart, most of them towards 6. As we wrapped up each wave, the data was available in production, but we chose to have a soft open. So even after the electrical parts launched, we didn't tell anyone. We decided to wait until they were all done before we made the announcement, before we did the training. If people found them in the meantime, it really didn't cause any trouble, so we were pretty safe there. This chart is a simplified view of the steps we went through. We don't have time to go through all those details here today, but on the left are the steps for migrating the tree from one system to another. On the right, the steps for moving the part metadata. It was tedious, but it worked. Now, this was no small feat, but we think it was worth it. Breaking the work up and getting help from stakeholders made it much more manageable. I like how the donut chart here helps visualize the tree with all the nodes. For example, in the upper right, you can see the electrical components branch. The numbers on the slides are from when we launched in the spring of 2016. Currently, we have about 19,000 parts classified into around 460 nodes. And I think our attribute count is pretty comparable to that 1,100. So we've had a fair amount of growth over the last year. I thought I'd share a few quotes from users. Dallas talks about how classification increased efficiency for part management. Jason's a design engineer, and he has a lot of parts memorized, but he sees this as a great way to find other parts when he needs them. So if he's got a new design, he maybe remembers the numbers for some of those existing parts, but he needs to search by attribute for some capacitors, resistors, whatever it might be. And Darren used to be a design engineer. He's now in sourcing. He wishes he would have had this tool when he was in design. So we learned a lot during this project. First, start small. You can always add more parts, nodes, and attributes later, and that's pretty much how we've planned it. The idealist in me thought an industry standard was possible, but each organization is unique. It's okay to develop your own, but learn from those industry examples. And get help from your stakeholders. Having commitment from our part data experts was critical to our success. And since we've lived with the system for over a year, we've got some other things that we learned along the way. If you let them, users will keep tweaking the data. Resist the urge, at least initially. Don't let perfect get in the way of better. Fix the things that are broken, but don't get mired in tweaking every little thing. And that's where governance can help. I didn't cover governance today, but it's important. There needs to be a mechanism, rules, and people in place to keep things on track. This is still an area of growth for us. And existing users are slow to adopt. For us, the old ways still work. You can still search in our ERP system for a part. You can search in our SharePoint system for a part. You can do wildcard searches in Windchill and find it without using classification. So there isn't a strong motivation to change. But for the people who found it, especially our younger engineers, our newer employees, they do appreciate the new method. So find ways to promote and demonstrate the new benefits. I spent most of the presentation talking about our buy parts. What about the rest? From the stats slide, you could see, if you did the math quick, that we're only classifying about 5% of our parts. So I really want to address that. I think if I did the math right, Solar Turbines is about 35%, and you'll hear a much higher number from Lewis when he comes up. So we want to move on to our assemblies and our make parts. We'll go node by node based on business value. I also see a lot of opportunity to share classification across our other enterprise systems. What value could we get by making this available to ERP and our service systems? So we're thinking about how to do that best. Thank you. I hope this has been interesting and valuable. Up next is Lewis Lawrence from Weatherford.
Hi there, and thank you very much, Brian. So I'm Lewis. Hope you can all hear me okay. And I'm an IT manager with Weatherford, and I'm also a long-term Windchill flunky. And a flunky is a liveried manservant or a person of menial labour. If you've been around Windchill a long time, you'll know exactly what I'm talking about. Weatherford are an oilfield services company, and the blurb here is right from our website. We are very global. We have 30,000 employees. And wherever there's oil in the world, you'll find Weatherford. A lot of our staff are customer-facing staff, or people who are actually on rig sites. So the 30,000 number is much larger than our Windchill users that I'll talk to in a minute. So we've been a Windchill customer since, I think, 2000. Before that, we've had Creo, or Pro-E as it used to be known, from the mid-90s. And we're pretty much all the way on Windchill functionality. We do not use npm link or option modeler, but we do have config management, change management, classification, etc. We've always used classification with Windchill since the very first install back in 2000, back when it was called Sourcing Factor. 2,800 active users at the moment, 1.5 million parts, and they're all classified. Now, when I say they're all classified, they're not all perfectly classified with beautiful attributes. A lot of them are just sort of dumped on a product line classification node, a lot of the converted in data. But in general, it's pretty good. The classification taxonomy you see is very evolved. There's lots of nodes there. And the classification is very discrete, and the majority of parts, and definitely all new parts being created, are very high quality. That's rich data. It's properly classified with good attributes. So a lot of our data came in by way of migration. Although we've been using Windchill for 17 odd years. We haven't keyed over 1 million parts in that time. Most of that data was data that was in systems and that we migrated in as we rolled people onto Windchill and onto ERP. Along the way, one of our goals was to try and reduce duplicate parts, or more specifically, to try and get everybody using the same part in a system or the same piece of physical inventory. Obviously, if you're a collection of companies grown by acquisition, pulled under one umbrella, that can be quite a challenge when you've got different business systems people are using. So part of the enterprise project going to PLM and ERP was to get us to one single source of truth and one good number for doing business. So classification definitely helps with that. But I would argue in most companies, you could probably find your duplicate parts already by looking at your business system data. You could go to suppliers and orders and descriptions and fields like notes fields in your ERP system for manufacturer part number. There's no doubt in that classification and attribute make that easier. But even then, when you've identified your duplicate parts, that's sort of the tip of the iceberg. The hard part then is what do you do with that information? How do you get rid of or consolidate out or displace the part numbers that you no longer want to use? And that's quite an involved process. You've got to update bills of material. You've got inventory in your business systems. You need to get over to the correct part number. You need to try and stop people buying the old part numbers. You need to update your CAD structures maybe. And then there's all the documentation you have that call out a specific part number. If you acquired some company, it for sure had its own numbering scheme for things like bolts and fasteners and whatever else. And those part numbers will be called out in service documentation, redress kits and all that sort of thing. So realizing that loading the data and then trying to do something with it once it was in the system, this consolidation process was really difficult. Instead, we did a lot of analysis during that conversion process, migration consolidation, or we call it part mapping. And the classification team, as they're looking at a data set from a legacy system that we're about to displace and a business unit that we're about to move to Windchill, they would work with experts of that data and say, you know, we found this thing in your data and we're pretty sure that's the same as this thing we have already in Windchill. And if they agreed on that equivalence, then we mapped those parts. So we took their number and we added it to the existing record in the system. And we took their documentation and we linked or associated that to the existing part. And the existing part was used in their bills of material and was used to represent any inventory they had on hand. Crucially, this meant that any legacy documentation didn't need to be touched. And that's really where most of the work is. So if we look at this O-ring part number here, you'll see from the screenshot, it's 00765-109. This O-ring actually has multiple identities. And these numbers were the other business entities, the former company's numbers for this same O-ring. And there's the headline number there. So at the time of creating this slide, we had 1.496 million OEM Windchill parts and 1.77 million of these legacy numbers. And that's a 15% reduction in our part number count if we just allowed those records to come in. And if you believe Graham's statistic at the start of this, where you're costing about $5,000 a year or thereabouts for these parts, that's a lot of money, and that's a year-on-year saving. So this is the same O-ring. You can see it's got 4 CAD models linked to it, a Creo model and 3 Inventor models. And the reason there's 3 Inventor models is because they came in from 3 different business units, all using Inventor on independent data management tools. And obviously, any of these parts, if pulled into a CAD structure, if that structure's owner linked to a Windchill part, owner associated, that's going to drive the correct go-to O-ring into any future bills of material. And that reuse of parts, that's where a lot of the savings are. And it's impossible to quantify. I mean, I can give you numbers and tell you how often we've reused this part. Would somebody have found it without classification? Probably. I'd probably found it by number. But definitely we are reducing duplicates. It's just hard to put a number on how much that's actually saving us. Something else we've been able to do, and we do all this because we can, because we have the data available, so it's really easy to use. We nightly publish data out from Windchill and ERP and other systems into a sort of BI framework or tool set for reporting against. And there's various reporting tools you can attack that with. But crucially, because we have the same item number in one system and we're using that consistently from Windchill right through ERP and all other business systems, that enables you to do really clever queries. So you can combine technical attribute data that's known good from engineering, all this lovely metadata we've populated, with all the business data from the business systems. So you can combine queries, an example here, classification, a material spec attribute, a diameter, which gets you from and to, and where there's inventory on hand and the cost is above a certain value. I think you can hopefully imagine for your own business how useful that could be. Basically allows you to get at almost any data you want and slice and dice the data returns to hone in on what you're looking for using classification and other attributes. Now, this was not something we set out to do when we started our classification project. And I would argue it's maybe what's brought the most value to our business. It's just used all the time. It's there and it's always been attacked by somebody. And that's a really nice return for your time spent classifying. Here's an example, a little bit fuzzy on the screenshot, apologies, but so some geography data, some technical data, and classification. In addition to flat out searching, having a query tool that people can click around and navigate in, a search index, has really added a lot of value to the organization. Before we had that, users used to really struggle with getting at good data. You know, you had the description or whatever might be available from ERP, but really a 60-character description field, when you've 1.5 million parts to sift through, that just doesn't cut it. But the classification alone, never mind any of the other attributes that you get, really adds some value there. For instance, if you search for the wildcard pipe in our data set, pipe's used a lot in the oil field, and you get a huge return. And being able to just say, well, you know, there's pipe here and supplies, there's pipe and raw material, there's pipe in all these product lines, to just click the one you're interested in and immediately dispatch stuff outside your sphere of interest, that's hugely valuable. And that augmentation of description by classification, it really adds a lot of value. Some of our equipment, you need more than 40 attributes to uniquely identify it compared to its peers. So, you know, you have a range of products, a family of products that all do something in a well, and the differences between them are very significant how they perform, but they're reasonably subtle. So a good example would be basically the same piece of equipment, but with a different thread on the bottom to connect to different downhole equipment. And you're trying to, somebody in customer services is trying to find a particular assembly with this particular interface and this particular pressure rating. Trying to do that with a 60-character description was nearly impossible, and they spent a lot of time either talking to engineering or trawling through documentation they had access to. But with an attribute set that's accurate and known good, they can quickly get to exactly the product they want without contacting anybody else. And there's a big time saving there that's also very hard to quantify. We're also using our classification to drive our general ledger for products. So general ledger, sometimes known as the nominal ledger for your accounting system, it's the core of a company's financial records. In Weatherford, one team manage that map that take you from a given classification node down to a GL code for the products. So that means anytime engineering release a new product, based on its classification, it's automatically assigned the correct GL code. And if you imagine, that's often quite high level. So an entire product family would typically be given the same GL code, a range of product families. If the business then decided, you know what, I'd like to be more granular on this, I'd like to better allocate inventory by GL based on product family, this map file can be updated and say, well, the nodes at level 2 all go here, these nodes at level 3, half of them go to this GL and half of them go to this other GL. And they can make that edit in the map, run the update, and within a few seconds, those changes are accurately applied in the ERP system. Before we had this, that sort of change would have been really quite difficult and time-consuming to implement. Somebody would have had to go sort of assembly by assembly and look at descriptions and decide, you know, where that was going to go. And that's definitely added a lot of value. It certainly made the bookkeeping more consistent. So with good attributes being applied to Windchill parts, you can drive business processes with them. They're a solid data point. And that also allows us to not duplicate that data because the part's sort of the master record that everybody's doing business against. So in some of our product line in the drawings, they've removed material specification from the drawing border, and that's now on the WT part. And that means that identical parts, the same geometry, made from different materials or with different coatings applied, can all use the same drawing. And that means that if I want a new part, like the one I did last week, but from a different material, I don't actually need to use the CAD system at all. Somebody can just, using a browser, point at Windchill, create a new Windchill part record, link to that drawing, and they put that through a change process, some engineer approves it, and right away we've released a new component with a different material. Here's an example of how we're doing that. So we have a WT part representation. The CAD data is pushed into that, and we watermark the material information onto that drawing on that WT part representation. The flip side of this is also true. There was a product line that identified an issue with certain combinations of coating specifications and material specifications. And it was easy to query and find where those combinations existed. And they were using this shared drawing. And a couple of people did some work to ECN those. And it was just the WT parts. There was over 500 parts affected. And they affected that change in 2 days, which, if you did the edit, 500 CAD drawings would have been a stretch. Again, using good classification and attributes to drive business process, you can do your procurement or your sourcing using classification and attributes. That 60-character description was always going to be a struggle, and typically what most companies who aren't using classification do is have some sort of document or a spec doc or a commercial part purchase list or whatever they call it. And that's what they're using to drive vendors to supply the right equipment. The trouble with that sort of information is that information that's buried in a document or on the face of a print or something like that's next to useless to the rest of the organization. You can't query against it. You've got to actually open the thing to know what data's in it, and it's just a lot slower than having than using attributes. So here's a piece of raw material. This is this part information page I was showing you. This time for a commercial part, so there's no drawing for this part. But this neatly defines what we expect from the vendor when they supply this part. So we classify all our assemblies and we populate technical attributes on those assemblies. Now often those attributes are the same data that people want to search on, like pressure rating, casing size, max temp, min temp, useful information for the product. Well, in addition to searching on that product, that's data engineering or creating as part of our new part introduction process. Somebody's defined classification, taxonomy, and templates that make sense for that product, and the required technical attributes are necessary to get that part classified. There's a constraint to force that they be required. Well, those same attributes are also useful in technical publications. So this equipment here is a connection downsize, look at 3.5 inches. And associated to this assembly, there's some arbortext documentation. And these are programmatically created server-side and associated to this assembly. And in this document, the attribute values are present. We also have one for the bill of material. And then the contents of this document can be referred to in other arbortext documentation. Now what's clever about this, or particularly useful about this, because really saving the initial keystrokes, you've just saved somebody copying and pasting. But these documents' content, these linked associated arbortext documents, those are maintained as the part changes automatically. So if this part goes through a change process, if any of these attributes change, this technical publication gets updated semi-automatically during the change process, and the publisher or the technical author alerted to the need to do this. And this is a customization we've done, but it is reusing, again, classification and attribute data. And that's possible because there's just an expectation that that data is going to be on new product and that it's going to be correct, because it's coming out engineering and goes through a change process. So that's everything I had to share with you. So I think at this point it's back to Graham for some discussion.
It is indeed. It is indeed. Thank you, Lewis. So three very different companies, three very different aspects to part classification, but I think three different ways of looking at the value of part metadata and its reuse throughout the company. So we have about 25 minutes for open discussion. So our three panelists will remain online and will be available to answer questions. So if you do have questions for the panelists, feel free to use the Q&A tool that you'll find down at the bottom of your screen and enter some questions. I can see we've already got some questions coming in, and we'll try and get to those questions as swiftly as we can. So maybe just to kind of kick off the discussion, and here I'm going to bring back in all three panelists, and this is just going to be free form, back and forth. So one of the things I'm interested in is, we talked about hard and soft benefits. Hard benefits might be like an example of what I gave at the start of this presentation, where things are measurable. And soft benefits, I noticed quite a few times, Lewis, as you go through your presentation, you're saying it's kind of hard to quantify, but we're seeing real value. So maybe the first question to the panelists is, have you been able at all to quantify some of the cost benefits that you've got. And the reason for asking that is we all know that those are the kind of things that our management love to hear. So maybe I could start the ball rolling by picking on Kat, because Kat, I know you shared with me when we first met an interesting example of how you've measured things at Solar Turbines.
Yeah, thanks, Graham. No, I completely agree with you and Lewis and Brian that this is actually a very difficult effort to quantify. And typically, I kind of refer to it jokingly to my management as air in the room. Usually when people go to search a database, if they can't do it, they just can't believe that you can't do it. But no one really thinks about how much work it takes to make a database searchable. But one of the ways that we've incorporated a strategy to quantify the benefit is we did a project very similar to the example that you gave at the beginning of the presentations, which was we assessed what we thought the value of creating a part was and the value of maintaining that part. And then actually in our new part creation wizard, we added a step where we give our users an opportunity to self-report whether they find a part that they can reuse or not. So we actually have a self-reported tracking of how many parts we've been able to not make since we started tracking a little bit under a year ago. And the savings has been really significant when we do the math.
Great. So I love the idea of being able to automate and track and have the system kind of help you roll up those numbers. So how about the other panelists? How about Lewis or Brian?
We don't have anything like that. We do have a new part introduction process, a request process for library parts that could return that, but I don't have statistics for how many parts they're not setting up because of that. I only know how many they're actually creating a month.
Yeah, and we're about the same at Daktronics. We're not keeping any metrics on that in particular. It does seem, there's anecdotal that it's easier to find a part, things like that, but to try to put numbers behind it, it's very difficult.
Yeah, I think that was clear from some of the quotes that you put up, Brian. I thought some of those quotes were great. That's what I put in the kind of the soft benefit. It's clear that people get benefit from it, but it's kind of hard to tie down to actual numbers. And maybe we could take one of the questions that come in online. And one of the questions is, do you mandate the classification on part creation? And is there that kind of rigor at the initial phase of part creation? So maybe Lewis, if you wouldn't mind kicking us off on this one.
Yeah. So yeah, we do mandate part classification. So for a part to become released, then it automatically pushes over to the ERP system on release. For it to become released, it has to be on a change notice, and that change notice is performing certain data validations against that part. It has to be classified on a terminal node, and its attribute values have to meet certain criteria. So whenever we have a list of allowed values for an attribute, so let's take color. If we imagine we're using color, we'd have blue, red, pink, and then in the last one we always have to be determined. And that allows people to get past the edit attributes screen and to classify the part and to maybe request that allowed value be added. And our change process that's controlling the release of the part, it does not allow you to release parts if the attribute value says to be determined. You can release it as a prototype, but you can't release it.
So really a fair amount of rigor at Weatherford.
Yep.
At Daktronics, we're a little more loose with that. I mean, we do have a new part process for the parts that we are doing, commodity parts. And so there'll be someone who reviews and approves that, and they'll verify that it's been classified. But for many of our other parts, we're obviously not classifying them yet.
So at Solar, it's kind of a mix. We do require that new parts that are created be classified on terminal nodes and that the attribute values be sufficient to populate the name. But we use some different part objects for different reasons. So we actually have a couple of part types where you can decide whether you want to classify it or leave it unclassified. But for any of our true component parts, we do require a classification.
Great, thank you. I have a question here. It's actually, Louis, it's specifically for Weatherford. And I think you inspired the question by talking about sending parts to ERP. So the question is, do you transact your parts and structures to ERP for basic part information?
Yes, we do. In fact, all parts have to start live in Windchill. No user can key directly into our ERP system. And that's really part of our master data management strategy. So you've got to create a part in Windchill, you've got to classify it, and then it's got to be approved by somebody who's authorized to approve parts for that classification node. So we have this idea of data owners. If you look at our whole product line portfolio, for every slice of that pie, there's a data owner who's ultimately responsible for the data in there. And they say who gets access to the parts, they say who can create the parts, and they say who can check and promote their parts.
From a Daktronics perspective, this was one of the key things that got user adoption when we launched PLM. We forced people out of our ERP system in terms of creating parts, and they had to be created in Windchill. And that basically prevented anyone from going around the system, and it drove more users in and really helped from that perspective.
Was that a big culture shock, Brian? For it's clearly a change in process, and I'm just wondering, how do you execute a change in process like that and get people to buy in?
Yeah, it was a big culture shock, but I can say that most of the people who were creating parts were in our engineering areas, and they're not a big fan of the ERP system. They grumbled and groaned about it, didn't like it, and so we presented them with something that was more user-friendly, that was designed for engineers creating parts. And in the end, they saw that and they liked it. I'm not going to say they love it, but they prefer not to have to do the work at all, I suppose. But they do like it better than what the other alternative was. So that, in the end, was a positive.
Kat, how about Solar Turbines? Do you have a similar policy? Do you create parts first in ERP, or do you create them first in PLM?
We create them first in PLM and then release that data to ERP. We're a one-way transfer of information that way.
Okay. All right, thank you. I have another question from the audience here. Attribution is a big time and money commitment. I think all three of you mentioned that, right? This is not for the faint of heart. But the question is, are you aware of any AI-based or pattern recognition-based classification for a company that's just starting? In your dealings with this, Brian, I know, for example, you seem to do it using Spreadsheet, and it was pretty labor-intensive. I'm just wondering if in your investigations out there, if you've come across anything that might make this kind of part cleansing a little easier.
I'd say when we were tackling it, kind of brute force was the path that we chose. Since we've been out talking about this a little bit, like after I presented at LiveWorks and such, we've learned that there's maybe some folks out there, consultants who specialize in this kind of thing. I can't vouch for any of them, but it's worth someone looking at, if that's what you're getting at.
Yeah. We one of the services that we as PTC offer is what we call a value-ready deployment, which is the ability to work with some of our consultants to be able to kind of airlift that initial ingestion of parts. And we work with a third party. I'm sure they wouldn't mind me mentioning the name, but we work with a company called Convergence Data. They have a lot of skill in this area of data acquisition and part data cleansing. So I think the tools are out there, and the knowledge is out there for those people who are getting into this for the first time.
So I would add something there, that you have a data source today. Your company's doing business using something, and business is running information. There are tools to help you extract from that, and there are tools to maybe help you slot parts, and whatever the tools are, though, you've got some third party who's not integral to your business, and they're going to give you back master data that you're then going to use to do business on. You need to be very sure that's good. And for most companies, that review process and that, that yes, this is accurate checkbox is still quite a lot of work. And while you can help, or you can get third parties and tools to help, personally, I don't feel there's any magic bullet to help do this for you. It's just a case of rolling up your sleeves and getting on with it.
Yeah, and as we were working through this, our IT group found a consultant that specializes in data that they work with occasionally, and they proposed building this tool for us, and it would be this one-time use tool to go through and do this classification and the loading of the data, and it was going to cost a substantial amount of money. I won't share the number, and they couldn't guarantee that it would work, and so that just really kind of left us feeling like, to Lewis's point, we needed to own this.
Yeah, when solar started, oh, sorry, Brian.
No, let's go.
When we got started, the original team was actually a group of part experts, and they essentially were sort of chartered to create a legacy by helping define our classification structure. But before they got started with that, Solar actually brought a consultant in to really teach that team the fundamentals of what classification is and what attributes are, and sort of help them create some ground rules around how they wanted to design that framework. And after that internal team worked sort of consistently on their own for sort of a couple of years on end, getting it ready for our parts link deployment. There are some other sort of interesting ideas on how to do this when you're first starting out. Solar has not utilized these, but it doesn't mean that they're not valid. And one of them is sort of like a shape recognition software tool that I've seen kind of on the periphery of being useful. But if you have a model-based definition opportunity in your data set, you might be able to utilize that to identify some of the classification levels. I know that I heard about another company, I think at LiveWorks, not this year but last year, who was doing sort of the same type of deal, but looking at 2D drawings and doing some pattern recognition on drawing notes and drawing different configurations and drawing shapes. So there are some different perspectives you can take on how to start sort of cutting this data up and making it more manageable. Another thing I put out to you is actually Solar agrees with Daktronics that having our entire database classified is kind of a nice to have, but it's not a necessity, particularly because we do significant amounts of custom content. So when you're looking at starting out, identifying that critical, valuable data set is really important. And the likelihood is that you're going to have the resources around your organization that really understand that data. And being able to capture that from them as opposed to doing a huge research project on something that you may have sold a decade ago but never have sold again, is going to be more valuable to your organization than trying to look at 100% of your data set. My opinion.
Good advice. Good advice. Thank you. So it sounds like there's no real kind of silver bullet when it comes to data loading. It sounds like there are some tools out there, some of them more experimental than others. But I guess I come back to Lewis's comment, which is, this data is going to be used and reused many, many times downstream. So you just can't avoid the inspection by skilled people to make sure that that data is good to go.
So I'll add something to what
Pat
just said.
Oh, go ahead, Lewis. Yeah.
Yeah, when we were taking people live, and most of our data in Windchill came in from a migration process, as we looked at their existing data, we applied some selection criteria to that. So on open order, in inventory, transacted on in the last 2 years, et cetera, and we selected the parts that they wanted us to take forward into PLM and ERP, and that's what we classified. And obviously everything new that's set up in PLM has to be classified as per our process. So we did leave a lot of data behind.
Yeah, that seems to be a pretty common theme amongst the three panelists. That I'm going to use Kat's example again of the elephant. Right? Don't try and swallow the whole elephant, but take it in chunks and prioritize the data and start with that, because that's where you get most value. I have a question here that's, Brian, this is directed towards you, and it's really talking about electronic components. And it says, because electronic component types have significantly different attributes, resistors, capacitors, so on, along with common attributes, sizes, so on. Who makes the decision on classification attributes?
That's a great question, and it's complicated and probably multiple answers there. When we started, I mentioned that we had workshops, and we would bring in subject matter experts for each area, and maybe not super fine granularity, but someone who could speak to that. And so what came out of that was our proposal for what those attributes ought to be. And for each node, so resistor would be a node, capacitor would be a node, and then there'd probably be nodes underneath those for different types of capacitors, for example. And those decisions were made by that team. Then we had, a little bit more consensus building out more broadly and fine-tuned it. Now, that's what we launched. Since then, I mentioned the need for governance, but at the end of the question, it mentions component engineers, and that they are a big part of this. We work very heavily with our sourcing component engineers to make sure that the attributes are correct, the data is good. If there's some new classification node, it's likely to come from them. A new attribute that they think would be valuable, it comes from them. As we get more of our governance in place, I think that'll be a little bit broader group, and there'll be a little bit more consensus building at the time. But right now, it is the component engineers who make a lot of those decisions.
Thanks.
Hey, Graham, I know that question was for Brian, but I'd love to chime in on that. So the original team that built our classification schema, one of their mandates to our management sponsors was that a governance team in perpetuity was necessary to defend the integrity of the classification schema and to make sure that the schema continued to grow and evolve to accommodate the new needs of the business as we innovate going in the present and going forward. So one of my responsibilities is actually to chair the taxonomy and metadata governance team at Solar, and it has representatives from all around the enterprise. We meet once a week for an hour, and we actually bring any proposed schema changes to that team, and that team approves the change in collaboration with whoever is requesting the change before we actually will update our schema.
That sounds consistent with what we want to do.
Mm-hmm.
Yeah, for anybody starting out on this path, it's really important that you have some governance in place. And you kind of need the governor to be a bit like a referee in a sporting match. They're a little bit impartial so that they can make decisions without too much emotion. Early on in this classification process, I was once in a heated meeting where two otherwise sane individuals had a stand-up screaming match about how special O-rings should be classified, and I really questioned my life decisions when I left that meeting.
Believe it or not, O-rings have come up in my last 2 meetings.
Oh,
happily, we don't use a lot of O-rings.
Imagine ending your career getting killed over an O-ring. Doesn't sound like a good epitaph. So one thing that came up, from all three of you, is that this is a significant amount of effort. I like the idea of reducing the effort by starting small and picking the data set and get the ball rolling. But what I'm really interested in is going into it. How did you justify the original upfront cost? And then kind of looking back in the rearview mirror, do you think that you achieved the original objectives, or were you surprised by some things? Maybe Brian, I could pick on you to get the ball rolling on that one.
Yeah, great. So as far as making the decision and getting approval to go ahead with classification, it was really rolled in. With the timing, we launched PLM in 2015 and with classification in 2016. So it was all really part of that original pitch to management for doing PLM, and so it's all rolled up into that. And just like with classification, even PLM overall, it was difficult to quantify all the benefits. It was a challenging pitch to make, but we had put that together. And one big piece of it was we needed it to be easier to find our parts, and that resonated. Most of the people in management have done some type of detailed work and have had that kind of struggle, and so that did resonate. And now in hindsight, I think we haven't fully achieved the value yet of classification. I think we're going to need to have more of our part types in there and get more of our systems connected so that we can do some of the things that Kat and Lewis have described.
Right. Thank you. Lewis, how about you? Going into that, how did you justify the project and getting into it?
Yeah, ours was justified as a way of getting everybody onto a common part number as they went live on PLM and ERP. And that definitely made it easier. And the fact that classification of the data and analysis of that data was a requirement for that go live. And that was kind of a double-edged sword, because the go live for ERP and PLM had to happen on a month's end to displace the legacy finance business system. And that gave us, this crunching deadline to meet for those go lives. We learned a lot as we went, but that was the initial justification, was to get us to a single source of truth in ERP and reduce our part number count. We've definitely successfully done that. But now we're in that kind of lofty position of having all this data available and being able to use it for all the cool stuff I kind of showed you. It's just become normal and part of business process at Weatherford. And now we're here, nobody would ever go back. But if we were to start out again and somebody would ask me to justify it, I would still struggle to do it.
Yeah, I think we're back to Kat's analogy of the air in the room, right?
Yeah, an analogy I've quite often used is I can remember a time before cell phones, and everybody had the idea of a cell phone, I guess, from the Star Trek communicator this thing you could hold in your pocket and you could talk to anybody anywhere. If I could go back to my teenage self and say, yeah, what value would you place on a device you could hold in your hand and talk to people? And how would you justify the infrastructure and setup of that based on my idea as a teenager? That's kind of the analogy. You don't know what you don't know.
Mm-hmm. I think it's a little bit of a leap of faith. I believe that the benefit's there. We just have to get there.
And don't our management just love the idea of a leap of faith?
I've never said that to them.
I think for solar, the burning platform was definitely getting our part naming to be consistent. No matter who was making a transmitter, we wanted the name to look the same, and also to just stem the tide of part duplication that was happening. So having those two things in control now, we're certainly not perfectly solved or realizing 100% of the benefit of our classification efforts, but we're getting there, and it's more and more benefit every day.
I'm just looking at my watch here and realizing that we're just about running up to the end of our allotted time. So I'm going to have to draw a line under the panel discussion for now. We still do have quite a number of questions unanswered in the queue, so we will try and make sure that we get those questions to the panelists and get you the answers at the end of the seminar here. So, I just want to extend a huge thank you to our presenters and panelists. I think this was very informative. It was great presentations, great discussions, great perspective. And I'd like to wrap up this portion of the webcast with some pointers to where you might find more information if you would like to follow up on your own afterwards. So first thing, just a little word about Windchill Parts Link. All of our panelists have deployed this software module. This is an optional component of the Windchill PLM product suite. This is the module that allows customers to build the types of high-quality, well-organized digital parts library that our panelists, Kat and Lewis and Brian, have described. Windchill Parts Link allows customers to build the classification hierarchies that are tailored to their own data and their company needs. And then this hierarchy guides the end users who are creating parts to attach this rich set of appropriate part attribute information that is so useful to the downstream functions. And then finally, PartsLink allows engineers to use the classification hierarchy and that attribute information to search for existing parts. So this increases the opportunity of finding existing parts. It encourages part reuse and lowers the instance of new part creation, with all the benefits that have been discussed by our panelists, including things like reduced product and supply chain complexity, reduced inventory, optimized spend with preferred suppliers, realized cost savings by eliminating duplicate parts, reducing errors and improving quality, avoiding part and supplier confusion in service, simplifying manufacturing with tooling and verification, and so on. So we've heard from the panelists that there's huge value to be gained by managing the quality of your digital parts inventory, but getting that started can be tough. And it's the sort of project that probably most IT or PLM specialists would probably only take once in their career. So PTC offers, through our worldwide customer success team, a value-ready deployment. This is a pre-packaged offering that allows customers to achieve rapid time to value by utilizing some trained consultants to guide you through that critical phases of deploying the parts classification and including software configuration and the classification taxonomy definition. And I'd like to leave you with some pointers to some additional information on the Windchill solution and PartsLink in particular. So here's some additional resources that you might find helpful. There's the PartsLink datasheet with a bit more information on Windchill PartsLink. Next in our series of tech tips, we'll be discussing parts classification features and functions in more detail. So look out for that. That's an upcoming webcast. And then finally, you can at any time obtain additional information from our PTC website using ptc.com/plm-contact-us. And with that, I would like to hand back to Mike to close out the session for today.
Thank you so much. Just a reminder to everybody in attendance that if you have any additional questions, you can refer them to the speaker bio box containing contact information for all the members of the panel and myself. And lastly, of course, I just want to thank everyone for attending this webinar from Design World. This presentation will be emailed to everyone later today and will also be available at www.designworldonline.com.